I'm going to explain how to separate odd numbers and even numbers in a given array using 8051 assembly language program. So open Kill Microvision File tool and you can type program. Okay, this program, how to separate odd numbers in a given array. So first you have to give the address where your data, the given array is present. So move r not hash 30. There is immediate addressing mode. Move r not register with immediate value of 30, and it is the given array address. So you have to give some 5 datas in this location before execution, and after the execution you have to separate all the odd numbers into the one more address, okay, where that array starts from 50h. So move r1 add 50. Hash 50 is for storing only odd numbers in this location. That means we are separating only odd numbers into this array. So move r2 is equal to 5. If you want to have array size of 10, you can use 10 here also. So here for the demo, I am using here only 5 datas, or if you want, you can use 8 also. Any value you can put 10 datas or 15 days or 20 datas. You have to enter those values here. So I'm giving checking with 5 only. If you want, you can give 10 also. Next, move A is a label, back is a label. ASK back and colon. Move A comma at R naught. So it is a indirect addressing mode. Move accumulator the content of address specified by R naught. In the R naught, what is there? In the first line, we use it. Move R naught with 30h. So R naught 30h is there. The content of 30h will be moved to the accumulator A. Okay, now what is the algorithm for check the number is odd or even? Okay, we have binary number 0, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1 like that. No? So you can observe uh, for all the even numbers, LSB is 0. If the LSB is 1, then the number is odd. Okay, 0 means, see here, for 0, 0, 0 will be there. For 2, 1, 0. For 4, 1, 0, 0. For 8, 1, 0, 0, 0. Okay, then for 10, 1, 0, 1, 0. For 12, 1, 1, 0, 0. So all LSBs are 0, 0. Similarly, for odd numbers, 1, LSB is 1. 3, 3 means 1, 1. So LSB is 1. 5 means 1, 0, 1. So again, LSB is 1. So by checking LSB in a LSB, that is in a given 8-bit number, you have to check the least significant bit. If your least significant it is 0, then the number is even. If the least significant bit is 1, then it is odd number. So that is algorithm. So we have to first get the value of that first array content into the accumulator. Okay, now here is an accumulator. Now I am checking only the bit. I am using bit instructions. So JNB means jump if no bit. Okay, bit means JB means jump if bit is set. Okay, bit, which bit you have to specify in the instruction itself. So for accumulator you have to use ACC. Okay, for these instructions, ACC is nothing but A only, but don't use A point 0. You have to use accumulator ACC point 0. So jump. Okay, ACC is this after dot. Okay, observe here after dot 0 is there. No, that is 0th bit in a given 8-bit data. Okay, LSB is the 0th bit and maximum is 7th bit. 0 for 0th bit, next 1 bit, 2 bit, 3 bit, 4 bit. Now, so in that one, first bit is 0, last bit is 7. So 0 to 7 is totally 8 bits. So we have to check only accumulator 0th bit, that is LSB bit only we are checking. So if this bit is not set, so J and B means, so no, we have to, that is a even number. So you should not move that value to the odd array. So that's why you have to skip this instruction, which is actually moving to the a destination, that is the 50h location, that we are skipping this. Okay. So if J and B, no bit, if it is not set, okay. Jump if no bit means not set. That bit is not set. So that means it is 1. Okay. Then if it is 1, then only if it is no bit, it should jump to the skip. Else, what you have to do, it is a odd number. So you have to move at R1, comma A. So accumulator content, the data is present. That data should be moved to the address specified by R1. In R1, we have 50. So in 50th location, that odd number will move. Again, you have to increment R1 because the next odd data also you have to move into the next location of that's 51H you have to move. So that's why you have to increment R1. That is, we are incrementing destination location, which is odd number location by 1. Okay, here jump if no bit, skip no. Here also you have to get the new data now. New data, actually data are present in 30H, which is in R0. So you have to increment R0 also so that we can check the new data. So increment R0. After that, decrement R2 register. R2 is a counter which is having the size of the array. It is not equal to 0. After decrement, if it is not equal to 0, jump no 0. If R2 is not 0, jump to the label back. Back is a label here. So it will go back to the line number 6 and it will get the new data from the 31H2 accumulator. Again, it will check LSB bit. If it is 1, it will move it to the incremented value of R1 location, that is 51 location. Else, if it is 0, it's an odd even number, you have to skip these two lines. So jump to label skip if it is no bit. Okay. So this will repeat 5 times. Every time if the odd number comes, that will be moved to the 50th location, 51, 52, 53 like that. And if it is even number, no data will be moved here. So let us see this program now. I'm copying this program. I'm writing first only separating odd numbers. After that, we can convert this one to the separate even numbers also. Okay, now let me do this. Let me remove the previous program. If it is running, you have to stop the debug and you have to remove it. Now it is not running actually. If it is running, it will not show remove. First, you have to stop the debug and after that, you have to remove this. It will ask for RE2 to remove this file from the project. From the project, it will be removed till it will be there in your folder. So now I'm adding new item to the this I'm writing ASM file. So I'll write separate odd from the given array. So here I will take the program. The first line is a command started with semicolon, write an ALP to separate odd numbers in a given array, and we are storing those separated odd numbers into the new location, that is 50H. First, you have to specify where your given array is present. So move R0 with 30H. Okay. And R50H is location for storing odd numbers. Now build target, which you have to check any error is there or not. The build window, you can see there is no error, zeros and zero warnings. So I'm starting debugging. Next, for this program, peripheral port is not required, so you can close it. And we are giving data from 30H. So you have to open memory window 1. You can open by clicking memory. 4 memory windows are available in 8051. You can open here or from the view. Also, you can open memory window 1. If you click one time, it will visible. One more time, it will disappear. So it is already there. There are 4 memory. By clicking tab, you can change it. In the memory window 1, you type 0x30H. Okay, now you have to give press enter. After pressing enter, you should see here D colon 0x30. By default, all the data will be 0 only. See what is the data block size are given? 5. So 5 data you have to give here. You can double click and you can give any data here. For example, I'm giving 56. It is a even number. Then I'm giving 89 is a odd number. You can give 33 is a odd number. You can give 21 is a odd number. Even even number. Okay. Okay. Now five data are randomly given. Okay. You can also give like this. Right click, modify. Right click on the very first data and modify memory at 0x30. By using comma, you can give five random data. For example, 56H, comma 89H, comma H stands for hexadecimal. Okay. So like that you can give five data and enter. If you give any wrong data, all the data will not be taken. It will be still zero only. So if you give only proper five data, it will update. Next, let us do now one by one. Step over. Click on step over. So move or not with you click register tab. So see the output here. So move or not with 30H. R1 is 50H. R2 is count size 5. First data is taken. Move a comma at R0. First R0 is 30. 30H content is 50. See, observe the memory window 1 year. The 30H content is this, 31H content is 89, 32 content is this. Okay. So here I aligned this width. You can adjust this width. Okay. You can adjust this width. So these are the data memories. Okay. You can adjust this 30. So here more data are there. If you reduce this, 40 will come here. Still I will drag this. Now it is 42. Still two more location you have to drag right side. Now it is 41. Still 41. Now it is 40. See 30. 30 to 3F will be there. Next to 40 to 4F. Next 50 to 50. Each line 16, 16 data will be there. So this starting address is 50, 30. This is 40. This is 50. So next one is 31, 32, 33. This is 41, 42, 43 like this. This is 50, 51, 52, 53 like that. Okay. So otherwise you can open one more window. There you can give 50H. If you want to see starting 50 only. There are four memory windows are there. You can use. Here I have selected 30 to 50. So you can observe data here and odd numbers you can observe here only. Okay, now first data is taken and now we have to accumulator. You have to check 56. How to write the 56? I will write here 56. How to write here? I will write here in the comment only. So 56 means okay. Possible. I will take 56 means 50. Okay, 56 H is equal to 0101 is 5. Okay, then 0110. That means this is the accumulator zeroth bit, first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit. This is seventh bit. This is zeroth bit. We are checking accumulator zeroth bit because if it is zero, it is a even number. If it is one, it is odd number. So we are checking only zeroth bit accumulator ACC point zero. We are checking only zeroth bit of accumulator. So in the 56, okay, in the 56, zeroth bit is 0 only. So it is a even number. We should not move into the 50th location. So it will skip. You can see now. So if it is no bit, jump no bit. The label skip. See, it skipped these two lines. Now you can see the pointer here. Now it will execute this line. So it will increment R naught. R naught is 30 now. It will increment R naught. Now decrement, we checked the first data. Now remaining four data we have to check. So decrement out of five, we checked one. So decrement one, it is now four. It is not equal to zero. So where it should go? It should go to the label back. Decrement R2. If it is not zero, jump to the label back. Back is line number 6. You can see the pointer is here. Again, take the R1 is incremented. See R1 is 31 now. Now content of 31 in the memory window, observe here in the 31, 30H content is 56, 31H content is 89. 89 will come to accumulator A. Observe here. After execution, if it is modified, it will be highlighted with blue color. Now 89. 89 how to write in the this one 89H. Okay, 8 means 1000 in 8 and 9 means 1001. So here LSB is 1. Here LSB is 1. So this is a odd number, we have to separate it and you have to move it to the 50th location. So there is a code. Now it will check if it is no bit, it will skip. Now actually bit is there, so it will not jump to this. So it will execute this. So move a comma at R1. R1 is having 50H. So from accumulator, it will move it to the at R1 location. So here at 50 you can observe in the memory window. Actually 30, 40, 50H all are visible in the next lines. Or if you want to open separate another memory window, give direct starting address as 50. So here only you can see 56 will come to the 50H location. Sorry, 89. 89 is odd number, no? 89 is coming to this location. I was talking about 89, second number, where LSB, 0th accumulator 0th bit is 1 now. So this data is moved to the 50H location. You can see here in the second memory window also, starting address is 50, here also it is coming. And in the first window also, in the 30H we entered 5 data. In the 50H earlier it was 0, now it is moved. So actually now 89 is coming separated and it come to here. It is picking only even odd numbers into the another array. So next increment or not. Decrement once again. Second number is also checked out. So you have to decrement that block size. If it is not 0, jump back to label back. Again incremented value of R naught. You can see here accumulator is 32. 32 content. This is 30th content. 56. 31 content is 89. 32 content is 33. So 33H will come to the accumulator. Now you can see 33 is coming to the accumulator. Again 33 means 33H means 3 means what? 0011 0011 33. Again LSB is 1, so it is also odd number. So this also should move to the 51H location. That's why we incremented R1 so that we can store the next number in 51 location. If you don't give increment R1, 89 will be replaced with 61. So you're going to lose the 89. So that's why after loading accumulator to at R1, we have already done increment R1 so that next number will be stored in incremented value. So now we have to move that second value to 89. Now you can observe 33. 33 is also odd number. It is coming in 51H location. Again increment R naught, it becomes 33. Okay, decrement R naught, and it is not equal to next decrement R naught. Again take the new value 21H. It is also odd number. It also should move to the next 52 location. See here 52 is location. After that increment R naught, increment R naught, and decrement R2. R2 is how much now? Still R2 is 1 now. So again go back. Now we are checking last data 88. In the 88, okay, in the 88, 88 means 100, 1000 and 1000. So 21 is, yes, I will write 21H and 81H also. 21 means 0010 is 2, 0001 is 21. So LSB is 1. Next is 88. So 88H means 8 means what? 100. Next 100. So here LSB is 0. So this is LSB 0 means even number. LSB is 1 means odd number. So these three numbers will come to the number array. So you can see here 89, 33, 21 is coming and 88 will not come. So and after that, this is short jump to this line only. Short jump dollar symbol means it will stop execution and it will, for infinite loop, it will be here only. So this is how to separate odd numbers, okay, into even number, odd numbers into separate array. Separation of odd numbers from a given array. To convert separating even numbers in a given array, you have to convert ACC dot 0, that is JNB. Instead of JNB, you have to give JB. Okay, So that I will show you now. Next program.